Chapter 6, Objectives. Use the kinetic molecular theory of gases to describe the properties of gases, describe the units of measurement used for pressure, and be able to change from one unit to another. Use Boyle's law, which is the pressure-volume relationship, to determine the new pressure or volume of a certain amount of gas at a constant temperature. Use Charles's law, the temperature-volume relationship, to determine the new temperature or volume of a certain amount of gas at a constant pressure. Use the temperature-pressure relationship to determine the new temperature or pressure of a certain amount of gas at a constant volume. Use the combined gas law to find the new pressure, volume, or temperature of a gas when changes in two of these properties are given. Use Avogadro's law to describe the relationship between the amount of a gas and its volume, and use this relationship in calculations. Well, I'll tell you, in this chapter, whenever we get to an equation, I suggest you write it down, because that way, and keep it in one place, that way you can quickly access it, because we're going to be just using equations left and right. So 6.1, properties of gases. As you are sitting, wherever you're sitting, listening to this, you may not feel any pressure pushing down on you, except for the pressure of this class, obviously, okay? All right. However, there's actually air pressure pushing down, and on all sides of you. Air pressure is pushing in all directions. So let's learn about these properties of our gases and how we actually are going to be measuring them, and what happens when we go someplace different. So first of all, the kinetic molecular theory states that this gas consists of small particles that move rapidly in straight lines until they hit something and then they bounce off. Okay? They essentially have no attractive or repulsive forces. They're very far apart. They have small volumes compared to the volume of the container they occupy. Actually, it's so small they assume that the volume the gas is almost nilch compared to the volume they're going to occupy as they're zooming around in that container. They have kinetic energies that increase with an increase in temperature. Now you think about that item right there, and you think about, okay, you don't leave your can. I had an acquaintance that left his spray can of like spray dust that you clean your computers in the back of his truck that had a camper shell on it in the middle of the summer here in Casa Grande, and it exploded, of course. Why? Because you increase the temperature and the energies of the molecules will increase, and they will make the volume get bigger and bigger until the can can't handle that pressure anymore, and it's going to explode. And it did about $1,200 worth of damage to the back of his truck. So, properties that describe a gas. When we talk about pressure, as we look at the table 6.1, you might think of air pressure that you put in your car. Yes, in your car tires. That is a type of air pressure, and you normally are going to measure, if you're in the United States, that tire pressure in PSI, which is pounds per square inch, which is all of an English unit. So the units of measurement actually, when we're dealing with them in chemistry, we're going to use more standard units of measurement, and those would be either atmospheres or millimeters mercury or torr or Pascal. In this class, we will be using those first three a lot. Volume, we're going to use liter and milliliter. Temperature, we've got to use Kelvin for our mathematical calculations. The amount of gas in the container, we are going to be using the moles, and we represent that with the letter N. When we're using that in our calculations using the gas laws. So anyway, so we have these four different things that we are going to be labeling with our formulas. So first of all, pressure. Gas particles are very small and have lots of energy. Well, of course, we already mentioned that. Pressure is the measure of collisions with the sides of the container. And I mentioned, for example, the blowing up of that can of air in my acquaintance's truck. Or what about if you are going to be accidentally, like you have a can of hairspray and you throw it out and somebody's burning a fire and you throw it in the fire. What do you think is going to happen? It's going to blow up, of course. Okay. So gas particles in the air exert pressure on us called atmospheric pressure. And so if we go higher, then that atmospheric pressure is going to be changing. Now, volume of a gas. The volume of a gas is the same as the volume of the container it occupies. It's not like liquid that's going to just hang out in the bottom of the container. It's going to be taking up that whole space. So the more collisions with the side of the container, the more you're going to need to have that container get a little bit bigger, and it's going to increase in volume. In sciences, the temperature of gas is measured in Kelvin. Well, we already mentioned that earlier. 0 Kelvin is absolute zero. Nothing gets colder than this, so no negative numbers in Kelvin. This helps with all the math. Temperature of gas relates to the average kinetic energy of the molecules. Here's the point. You decrease the temperature, you cool things down, the molecules are going to move less. You increase the temperature, molecules are going to move more.